All right, so let's get going here. So we left off last week doing a lot of review. So we'll do a little bit more, I think, regression, review on Friday, along with looking at another paper, which is up on Canvas. So if you go to files, create a few more folders to kind of keep some things, track of things. So you notice complete skeleton lectures, I'll kind of move those into those folders as we progress. However, anything that's like kind of relevant for that week, I just leave under the main files tab. So like next week, week 2 skeleton slides will get moved into the folder. But because we're using them this week, I kind of leave them up there just under the general files tab. I also have a couple of different papers we'll take a look at. Like I said, most weeks I'll post these after class Monday and expect you to have read them on Friday. These first 2 weeks, I said we're just going to go through them together in class, and I'll kind of explain like how we would like try to read them quickly or succinctly just to have enough knowledge and information that we need for the discussion of those papers in class. So this week, the stadium naming rights, that's just going to be something that I'll kind of pull open during class. The one that we'll review on Friday at the end of class will be this stock returns person conduct. Okay. So that should get that out of the way. And then we've got our skeleton slides for the week, which is, I'm using the complete version, but that's what we're going to be kind of start going through here today. Okay. Questions from me before you get going, starting out? So we did a lot of review of kind of supply and demand, thinking about, we might have a market for different products. When we start thinking about our sport examples or our sporting kind of industries, the output's not as easy as like a baseball bat or like, creating a physical product, right? So if we just kind of think of some more abstract ideas to think about what production or what output or what the quantity we're measuring could be, we can think about things like, okay, so Ford, right? What's their output? Well, that one's pretty easy, right? Automobiles or cars or whatever you want to think about, right? That's kind of our traditional one. But then we might have something like Facebook, right? So what would the output of Facebook be? It's a little bit harder to measure. So we think about trying to increase the quantity there. It might be, so they want to maximize ad space. How do they do that? By creating a higher output of users, right? And so they're going to put money in to try to attract more people, to try to build up that quantity of users they have, which they then sell to advertisers or, someone wants to buy ad space. What about Ball State? What's their output in a weird way? There's probably different measures, but hopefully the main one that they're focused on is degrees. Number of college degrees awarded, or students that they churn out, or however you want to define this, right? So we can kind of see like moving from a more like traditional, we kind of start to think about things that are a little more abstract, right? What about a college football program? What's their output? Like, what are they really trying? What are they often probably wanting to maximize? Fans, potentially. But we could also think about what's the actual output of the football program. They want to win. Right, the number of wins or the number of games they play, right? Wins will drive up the demand curve for their product, but the actual product itself is just the game that's being played. So whether it's increasing the number of fans, whether it's increasing my number of wins, that's just going to shift my demand curve. The actual output, the actual quantity would just be the games that we're playing, right? So we'll start to think about the production function a little bit differently than we do it with like traditional goods. I think I've got, we can think of, for now, quantity, let's think of as just the number of wins, right? So that's what we're trying to we're churning out different numbers of wins, right? So instead of Q, we can write this as W, right? Just notation difference there. Okay? So what things might influence the number of wins for a football team? So think about this. It really comes down to the talent, right? Now, so the talent of your players is going to then maximize or kind of alter the number of wins you can expect out of the team. So whenever we talk about the output of these teams, it gets a little bit tricky because it's always an expectation. It's always the predicted number of wins, right? Because obviously there's variance in kind of these games being played, and just because I think that I have the talent, that should equate to 10 wins. Injuries, things that are unexpected, there's different probabilities associated with each one of them. So here we're thinking about the number of wins, but probably to be more accurate, the expected number of wins. So like all of these, you can think about the decision for production is made prior to the season starting, right? We're targeting a certain number of expected wins. So we've got all these different positions, right? As we increase talent at every position, well, then we're going to increase the expected number of wins, right? If I go out and sign, I don't know, name the top quarterback that you like, right? If I got signed, the top quarterback in the league, well, that's going to increase my expected wins the following year. So if holding everything else constant, right? I have the same players in the other positions. So we'll kind of simplify this to start thinking about production function as just offensive and defensive talent. We could break this down and be more, refined about it and kind of do it position by position. But for now, we'll just think about two positions, offensive and defensive talent. So our wins is going to be a function of those two things. So generally, we think about like quantity as a function of, if you've taken labor economics, like labor and capital, because it might be how we would traditionally see it. Well, for us, our quantity, our output is going to be the number of wins. And that number of wins is a function of offensive and defensive talent. Now, we could obviously complicate this. Like my argument would probably be like, comma, what's the third thing that matters? Maybe coaching talent, right? Comma, another thing that matters. And we could go through and add in different inputs, but we'll kind of keep it simple to two for right now. Okay, so that's kind of our production function. So we then want to think about, in economics journal, we're always thinking about things on the margin, right? So as I increase my offensive talent or my defensive talent, how's that going to change the expected number of wins? Well, if I start from a point of 0, right, that first unit of offensive talent is going to increase my expected wins a lot. Once I get to the point where I'm like Alabama football, adding another top offensive talented player, chances are they're going to be sitting on the bench. The marginal change in my expected wins is very small, right? So we still have this same idea. We can almost think about it as, if you want to think about it as like, whether it's offensive or defensive talent. And then we think about kind of the number of wins from that. We're getting kind of this, right? It's increasing. As I add more talent, my expected wins increases, but that starts to do so at a decreasing rate, right? Once I get to a pretty high level of talent, adding more and more talent doesn't add a whole lot of a higher number of expected wins. Right? So here we're thinking about kind of the marginal production, right? Or what's the change in production from changing my inputs, this offensive or defensive talent, okay? So the way we'll write this, and this is probably a little more than we'll even often do, but I think about this as like, so we've got a function of offensive, defensive talent, right? When we're talking about marginal production, we're thinking about the change in the number of wins. So here I'll write change with like just kind of a triangle that represents the change in the number of wins. From, well, what are we changing? We can change two things. We can either change our offensive talent or we can change our defensive talent, right? So as I add more of each, hopefully those are positive, right? Adding talent to my team should change the number of expected wins by a positive amount. The problem is, if I think about the law of diminishing returns, and I could actually go one step further, is, well, yeah, adding talent is going to increase or change the number of expected wins in a positive way, but I could go to think about this as like taking the second derivative of this. So like change in wins from a squared term of change in offensive talent, right? It's probably going to be at a decreasing rate, right? I'm not going to make us go this far. All I really care about is when we think about the marginal production is positive for both. But we do want to know that it's diminished, right? So I think just giving a couple examples will kind of help solidify this in our minds going forward. So if you already have like the best quarterback in the league, oh wait, what did I have here? Okay, so I think the point I want to make here is a little bit different, but I won't use the slides to make this point. So if I have the best quarterback in the league, and I then go out and get the second best quarterback, what's going to be, I definitely increase my offensive talent, right? That's one of the most talented players in the league, but what's happening to the expected number of wins? I mean, maybe it's increased a little bit because these expectations will build in the probabilities of injury. And so then it is valuable to have that backup quarterback, but it's not going to add near as many wins as that first high talented quarterback I added, right? So we have this kind of diminishing returns to adding talent, right? We also might have some complementarity. So, for example, let's say I have the best quarterback, right? Well, they're going to add a certain number of expected wins. But if I couple that with something like I also add offensive tackles, right? I add in some of these offensive linemen who help my quarterback be more productive. Maybe I actually see, kind of think about here, initially, you can think about it as my marginal production might initially be increasing before it starts to decrease, right? So this is, in general, we talk about marginal production declining as a result of the marginal costs to labor increasing. Well, here our labor, like our players, are our talent. So as we're kind of adding more and more players, right, the marginal cost of adding more and more talent is going up and up and up, which is going to decrease our overall marginal production. But one thing we talk about initially is maybe my costs, my marginal costs for labor initially might decrease. Remember from any of your other econ courses why that might be the case. So I hire my first worker, they produce 50 units. I hire my second worker, they should be the second best. So on their own, they might only produce 40 units. But if I work those two at the same time, what can they maybe do? Starts with an S. Specialize, right? I can have one of the workers doing the first part of the production process, the second one doing the second, right? So potentially I have kind of this specialization as I'm adding more talent, right? I might get that they can fill more specific roles. Probably doesn't make quite as much sense if we're thinking about football, but if we're thinking about something like basketball where players can maybe play between multiple positions, but if I have a great player at every position, they can really hone their abilities to that one specific role on the team, right? You could probably make, with playing football as well, right? We can have people playing special teams or different positions on the defensive or offensive line, right? Just maybe there's initially some gains, right? Or that marginal production will increase because of this specialization, right? But for the most part, we're really going to be living on this diminishing portion, right? Yeah, and when we talk about this as the expected number of wins, it's going to get kind of tough when we look at the numbers because we're not going to be talking about adding 2 or 3 wins. Maybe the first units of talent we added our quarterback position to that, but from there on out, it's probably fractions of wins, right? There's so many players in the team that every single kind of unit of talent that we measure is just going to equate to a fraction of a win. So we have to start thinking about this a little bit differently. Maybe that could apply to quantities, but generally, like we can think of quantities being like 10,000. So then a fraction of that, like 1 or 2, still makes sense. Here we're talking about 10, 12 wins in a, 16, 17 games in a season. Well, each player is not going to add a whole game, right? It's going to be a fraction. Okay. There also might be the possibility, and we generally don't see this occur in practice, but it is theoretically possible, where I get to a point. So I have like my offensive talent here. Even if this is at like one position, let's say I've got quarterback here, right? Why could adding more talent actually lead to a decrease in the number of expected wins? This one's a little bit hard to envision.
Maybe financially, you can't afford to pay other positions.
Yes. So you're thinking about, you're correct. So let me assume that away for a second, because there's a more interesting reason why, right? Obviously, adding more talent, if you're sacrificing adding talent at different positions, but let's assume that we start to purchase talent where it's the most beneficial. So our dollars are being maximized, right? So let's assume that budget's not a worry for us. Why might adding kind of more talent, even within the same position of quarterback, be an issue?
Competition and morale in the locker room.
Yeah, right. So if you adding that talent creates friction between players or creates something that potentially might, you could even argue as far as like psychologically impacting the starter by adding a high quality backup, you could actually see a decrease in marginal production. Right? I think I might have the example here. This is like an old one now, but like back when Tim Tebow was very popular, but not that great of a quarterback, he went to a couple of teams at the end of his career, and like every game was like talking about when is he going to start. Well, as that kind of prolonged, you saw the starting quarterback's production decrease game after game. So having a high quality backup, yeah, you're adding more talent. You're protecting yourself in the case of an injury. But if you add too much talent there, potentially you get kind of this negative effect on your production, right? So kind of an interesting thing, kind of interesting way to think about it. I might skip through this and come back to this next class because I don't want to waste a whole lot of time on that today. I want to make sure we get through stuff now. So I'll revisit those slides kind of on Friday. We'll kind of revisit some idea of marginal production and kind of build in marginal costs. But for now, I want to kind of go back. It's not quite review. We kind of already reviewed this, but we have to throw in some additional things that I'll start talking about. So we talked last class, I think, in general, like these perfectly competitive markets, right? Every single person would be a price taker. We kind of have the equilibrium being where supply is equal to demand. We can think about profits are maximized where, so if you think about here, we'll revisit cost structures for a second. So let's say I've got increasing marginal costs in a perfectly competitive market. I can't charge a price anything different from whatever that equilibrium price is in the market, right? So in general, the optimal kind of profit maximizing output, we can kind of think about this as the profit maximizing output or quantity. I'll label these here as quantity, and then we have kind of like dollar amounts up here. Is going to be, well, I can't charge a different price for this good because I've got competition and people will just stop buying my good and buy the one that's cheaper. So I can't increase my price at all. So my marginal revenue is just whatever the price of that good is. So there we kind of have, well, where's marginal revenue equal marginal cost? That'll be the last unit that I can sell where I'm getting a net profit. So you can think about this as if I took the additional revenue that was generated from selling something and I subtract the additional costs. So another way of thinking about that is what was the change in the amount of total revenue I was generating from a change in my output? And then what was the change in my total cost from changing that output, right? Because yeah, if I produce more, I can sell more of it. I'll increase my revenues. But at some point, it becomes so costly, right? I've got to hire like really, there's only ineffective workers left out there. So if I want to increase output, I've just got to hire really, really bad workers, which means I need to hire a lot of them, paying a lot more money to get just one more unit, right? So I also have to be concerned, okay, yeah, my revenues are changing, but so are my costs, right? Well, if I take the difference between those two, I can kind of think about this as really it's the marginal profits, right? Now I'll write profits using kind of this pi symbol. It's just kind of, I want to say tradition. What is it? The general note, the accepted notation for profits in economics. So here, if I looked at the difference between my marginal revenues and marginal costs, I'm getting my, I guess we could think about this as marginal profits, right? So that's what I'm trying to maximize. Well, for every quantity here, I'm getting more additional revenue than I'm increasing my additional costs up to the point where they're exactly equal to each other. At any quantity past that point, I'm now adding less revenue than I am to my costs. And I'd actually just be decreasing my profit amounts, okay? So that's a perfectly competitive market. This will pop up throughout the semester, but not a lot, because generally, when we're looking at these sport industries, they almost all have a monopoly, right? We'll talk a little bit more specifically about why and what that looks like, but we'll review kind of the effects of the monopoly, and then today we'll really dive into the ticket market specifically. So a monopoly, hopefully we kind of remember, that's when you have one seller of a good, right? Or one producer, right? So this could happen because they own a key resource, like, for example, if you want to watch a professional football game, the NFL is the only league out there, right? Now, there might be amateur leagues, or it might be, college football or XFL or whatever it is. But in terms of a professional league, there's generally, they have that key resource, right? You could also argue that each one of these sports has a monopoly over, whatever that sport is in terms of the media outlets, right? If you want to put on broadcast an NFL football game, there is one supplier of NFL football games who's going to sell you the rights to broadcast that game. So we see monopolies pop up a lot, specifically in professional sports, but even at the amateur levels, there's not a whole lot of competition. not enough to get to these perfectly competitive markets. So we want to think about monopoly power quite often. Now, another reason why is government rights. This doesn't really apply to a lot of the examples we'll look at in sport, but just kind of a general review of monopolies. Natural monopolies are another one. Now, this does kind of pop up that potentially the reason why we only have one professional sports league is because given the cost structure and the amount of available talent, there's only enough talent given the cost to support there being one highly competitive or a league that can garner enough demand to make it profitable, right? So if there was another competing league that popped up with the NFL, potentially by having two professional leagues of equal talent, there's not enough demand to go around, they would operate at negative profits. Well, if they're both operating at negative profits, what happens? One of them would leave that industry. Now the one remaining might go from negative to positive profits, but as soon as another one joins, they go back down to negative, so no one's ever going to join that industry if it's a natural monopoly, right? Now you'll see kind of leagues maybe thinking that there is enough demand to support more than one. So we see examples like the UFC, there's like Bellator and some other competing leagues that actually can generate profits, and they may not have as quite high of a talent level, but they are able to kind of share a portion of that demand curve. We see things like the XFL trying to kind of, or what's the new one? Is it USFL that the NFL is trying to do, where they're not like direct competitors, right? And they might be able to share a portion of demand for that sport. But we're willing to see one sport often it's because we have a natural monopoly there. So firms will still choose to optimize their output where marginal cost is equal to marginal revenue, but it's going to look a little bit different than what it did before. So if we remember what this looks like, we've got some demand curve, and I'll get out of the way here in a second, some marginal cost curve, right? So for a monopolist, because they're the only supplier, you can basically think about like our marginal cost curve for the monopolist is the supply curve. Generally, our supply curve is like adding up the marginal cost of every single producer in that industry. Well, there's only one here. So their marginal cost is the supply curve. Well, where's marginal revenue, right? For the sake of this class, I think in your intermediate micro, this gets a little more complicated, but I'm going to keep things linear. So I'll make things a little bit easier here, all right? So if we have linear demand, our marginal revenue curve will always be twice as steep. So I think I've got this. Yeah, I've got the math here. It's not, I don't know, I'm not going to make you like reproduce this. But what you do need to know that is if I only gave you the demand curve, right? So we've got our demand equation. Price is equal to, has some intercept, some slope, and a function of quantity. Then our marginal revenue will start at the same place, same intercept, but be twice as steep, right? So the reason why, if you think about what's total revenue, so this might be a little review I don't have up on the board here, but total revenue is price times quantity. Well, if we have this demand equation where price is a function of quantity, I plug that into price. Now I've got this equation. Well, if I want to maximize total revenue, or I think about what's the change, or sorry, I shouldn't say I want to maximize. If I want to know what the change in total revenue is from a change in output or change in Q, I'll just take a derivative of that function. Derivative of that function. Well, A times Q just becomes A. B times Q squared should be Q. Right? So that's where that comes from. As long as we keep demand linear, we're always in this twice as steep marginal revenue curve. I won't use anything other than linear demand, and so the math won't be too complicated. Okay. Is this ringing a bell? Somewhat familiar. Couple nods here. So where's the profit maximizing output going to be? Well, where does marginal cost equal marginal revenue, right? Wherever that's at, that's the quantity that would maximize profits for the monopolist, right? That's the price they can charge, and they get to choose the price because there's no competition, right? We then go up to, okay, well, why would I just charge this lower price when I know that the consumer at that quantity is benefiting or marginally benefiting by wherever we're at in the demand curve. So I'm always willing to pay a price that's below or up to my marginal benefit. So if I'm the monopolist, why would I choose this price? I know that I could actually have gotten away with charging this price and they would still be net benefit. I can get away with charging that price. That consumer still has a net. I can go all the way up to where that last consumer is indifferent. And that's the price that I'll set to maximize profits, right? So, we generally think about firms setting prices as opposed to quantities. They know they want to target this optimal quantity to maximize profits. How do they do so? It'd be by setting whatever price we would be at that quantity on our demand curve. So go up, oops. I think this is just, I have my my animation set on. Any questions on this before we keep moving here? So we've got these monopolized markets. We won't talk about deadweight loss today, but that's something that we will revisit. Before we do that, I'm going to say, okay, we've got enough review now. I'm going to transition to thinking about a very sport-specific example. And when I say sport, I mentioned last week, might not be baseball, basketball, football. This could also be like art museums, stadiums for concerts. So we're really going to be thinking about ticket markets. Okay, so all of these sporting events, or thinking about concerts, we're going to have a ticket market where we're trying to generate revenue by selling tickets to these events. Okay, so this gets a little bit more specific, and we're going to be thinking about the demand for an individual event or game. So this isn't like over the whole season. This is just one specific event. So one game within a season. Okay. So earlier we said, traditionally, we've got this increasing marginal cost curve, right? However, it can actually be that supply is vertical, right? So what would that actually mean? So let's say we've got our ticket market. Think about the quantity of tickets we're selling and the price of that ticket. Right? Demand is going to be kind of more of what the traditional demand curve would be, right? For our first few tickets, the consumers who value it the most or get the highest marginal benefit will be the first people who would buy it at these higher prices. And then as we go down, start looking at more and more people who value it a little bit less and less, they'd be willing to pay slightly lower prices. We got our kind of traditional downward sloping demand curve. Right? Supply, however, when we think about that, represents marginal costs. Now there's a small, you can argue with me a little bit here and we'll talk through it. But if I've got a stadium, it exists, it is built. What is the marginal cost of providing one seat versus all 40,000 seats in that stadium? They're already built, right? Once I have the game, once the stadium's open, if I sell one ticket or I sell 500, doesn't matter. Right? The marginal costs are actually exactly the same. And what are those marginal costs? Zero. We would then see the supply curve be vertical once I supply my entire capacity. Right? So to provide one seat, there's no additional cost once I open the stadium up to have one or every single seat in the stadium. Right? So we're going to have marginal costs of zero. Remember, supply is still representing our marginal cost, but then at capacity, I can't provide anything past that point. So it's almost like if we talked about like quotas, like I can't go past this supply. That's, at least for this game. 10 years from now, if I want to build a plan to increase the stadium, but for the game, this current game with the stadium I've got, I'm kind of limited to whatever my capacity is. Okay. Now, there's some caveats to this. Why might you argue that the marginal cost isn't zero here?
The value of a specific seat, like 50-yard line or something.
So remember, so you're thinking about demand, right? If I think about that seat that's right next to the 50-yard line versus up in the nosebleeds, once I open the stadium, the marginal cost to selling that ticket it's there, right? That seat's there either way. Now I can generate a higher price for the ticket that's on the 50-yard line. So I'm talking about this like all tickets are the same. In practice, we would have to take a general ticket market and probably break it down into different qualities, right? So you can think about, here's maybe my, if you've ever been to Wrigley Field, like these are the bleacher seats out in the outfield. And then maybe you can even think about extreme examples where I've got the demand curve for my suites. Well, that's going to be much higher. I'm going to generate a much higher price, right? In fact, I'm jumping the gun a little bit here, but I think it's worth it. if I do have this supply curve, and we'll revisit why it could look a little different. Well, where is my marginal cost this was a perfectly competitive market. We'd end up at an equilibrium where the marginal cost is equal to the marginal benefit. If this market's monopolized, however, I've got a twice as steep marginal revenue curve. Marginal cost runs along the x-axis, so it's my marginal revenue down here. And then I would just go up to whatever price I would be at on that demand curve. So we would still identify the profit maximizing quantity where the marginal revenue hits marginal cost. But if we had different types of seats, so let's say we go here, and then I've got my marginal revenue curve, something like this, right? So it's a little bit sloppy there, but so I've got my marginal revenue for my suites twice as steep as the demand curve. Well, notice we get some weird things happening in the ticket market where sometimes my marginal revenue will hit my marginal cost at this x-axis. Sometimes it'll hit the vertical portion of my supply curve. If it hits the vertical portion of my supply curve, well, then I know that the equilibrium quantity there is actually just capacity, right? Demand was high enough to even maximizing profits as a monopolist, the optimal quantity, I hit capacity. Then I go up, well, what price would I get away with charging? Oh, no, it's not it. Sorry. I gotta go all the way up. It's my demand curve. I was looking at the wrong demand curve. Right? So I go all the way up to my demand curve for the suites, I can charge a much higher optimal price, right? But in terms of how much did it cost me to supply both those seats, once I open the stadium up for the game, I've got the same workers working the game. I paid the players already. Like that, a lot of my costs when it comes to providing these games, they're all fixed. Huge fixed cost of building the stadium, but once it's built, providing additional tickets, no cost. Right? Does that make any sense? Any questions on that before we keep going here? So this is, we still identify the equilibrium quantity where marginal revenue hits marginal cost. It's just that it's going to look a little bit different depending on where demand's at. If demand's pretty low, well, we might be hitting that marginal cost curve at that horizontal axis. If demand's high enough, we'll end up hitting our marginal cost or the supply curve where it's vertical, right? Or we'll hit capacity. Okay. So back to why might you argue with me that marginal cost isn't zero? So if we think about the situation,
You could say the more tickets you're selling, outside of the stadium, you're cluttering the city, and there could be more accidents and stuff like that.
So to the city, there might be some unintended costs to that. Even within the stadium, if you think about, I'm worried about fans getting rowdy, and I've got 50 fans or 50 people at a concert, as opposed to 50,000 people at a concert. What am I going to have to probably hire more of at that concert with 50,000 people? Security, right? So there probably is an argument that labor costs are increasing a little bit. Although if you think about a stadium, we're probably talking about, in reality, it probably looks like this, right? There definitely are probably some increasing marginal costs, just like our traditional models. It's just that they're so infinitesimally small, relative to what demand for that sport is, that it's just barely going to be running above that x-axis, right? And I think the example we're talking about 50 versus 50,000, that makes a little bit more, I'm using the extremes there. Providing 10,000 versus 15,000 tickets, probably need about the same number of workers in the stadium, right? But you could complicate this model a little bit by thinking there's a slight increase initially. But we'll use the extreme just to kind of make the point and show how some weird things can happen if you do have kind of this, even if it was slight increase in marginal cost and then hitting this vertical kind of supply at capacity. Okay. Questions on that before we I think I have another couple examples here. So we've got the constant number of seats. So some exceptions, I would say that probably face a steeper increase, but it's going to look even weirder. There's minor league stadiums. Sometimes we'll do this. I'm sure there's different concert venues, but have you ever been to I don't know, if you go to Emmons, right? if they don't think they're going to get a whole bunch of people, they might like section off some of the seats. So some of these, I've been to a AAA game before, and they had like, where was I at? Oklahoma City, and they had like a upper deck, but it was used for other things. And so for most of the games, they couldn't get enough people to attend the games. They literally had them tarped off. So they didn't have to spend any money on cleaning them, sending people up there for concessions. They simply had the lower level. So what they were doing was really like the first maybe 5,000 seats they could provide with no additional cost. They're hiring the same number of workers. But if they could ever get demand to be high enough where they want to open up the upper deck, well, now, right, their kind of marginal cost jumps up a bit because now they have to hire all the employees for the second deck as well. So you might get kind of this like weird kind of jump in our demand curve for things like that. We're not going to deal with any of those. But just to be honest and practical about, we could complicate this model a little bit. Okay. For the sake of what we're doing though, we'll kind of think about this nice kind of like L-shaped supply curve. And another example is like if you're choosing venues, right? The UFC, like if I'm choosing where to host my event, I don't have my own stadium, right? Paying for a stadium that fits more people is going to increase the cost, right? So there we might think about we have more of a traditional kind of increase in marginal cost as well. So thinking a little bit more about supply, and then we've got demand as well. For every single event, even if we're looking within the same sport, same team, different games might generate different demand. So not only can we compare like different types of seats for the same event, but potentially, think about the same team playing a game. So I'll use an extreme example like it. Let's say, who's the most true? So let's say Georgia is playing Alabama, right? What do you think is probably true about demand for that game? Pretty high. Right? They're kind of in the same conference. They're both really good programs, high quality. But what if Georgia, the same team, is playing a home game, right? Just like they were before against Alabama, but now they're playing Ball State. What do you think is probably true about demand, right? Probably significantly lower. Not picking on Ball State, the quality of their team, but like it's not a conference game, right? They're very different quality. Like you probably already know the outcome of that game. And so we can think about even for the same team, we're going to have all these different things that shift the demand curve, right? In fact, if we think about, I don't know, like the Chicago Cubs, you can think about they're playing a game on a Tuesday afternoon versus a Saturday afternoon. Which one probably has a higher demand? Saturday, right? We think about marginal benefits like the ability and willingness to pay. That's demand. Well, on a Tuesday afternoon, if I'm an average person, I don't have the ability to attend the game. I have to work. Right. And so we could see even within the same team, like even we're thinking about they could play the same opponent at different times of the week. So we've got all these factors that probably shift demand. Right. So what are some things that might shift demand? I think I'll just go through here quick, put everything up there. We could think of a bunch of different examples. But right, timing. So I already used kind of day of the week, time of the day. When I think about college sports, I was actually just having this conversation with someone. The best tickets to buy in terms of you can get a low cost or low price are games that are like over winter break for some of these bigger sports teams. So if you're thinking about like IU or Purdue basketball, you could do something like this, where we're thinking about the quantity of tickets sold and then the price they can get. So we've got, maybe this is the demand. I don't know, let's say for a February game when there's a bunch of students around, student tickets are, there's a lot of them available. We've got our supply curve or the number of, we could even break this up, not the capacity of the stadium, but maybe the number of student tickets that are available or tickets are selling to like the student section or something like that. Well, they have a monopoly over the market for that team's games. So we can think about, I've got my twice as steep marginal revenue curve. So I can figure out what my optimal quantity and my optimum, actually, we did February here. So instead of 1, let me just write that in here. And we can get our optimal price, right? So where did marginal revenue hit marginal cost? That's my optimal quantity. Go up here to that demand curve. That's the optimal price. If I'm thinking about games that are played over break, right, there's just not as many students around. So I'm thinking about my market demand curve. It's adding up the marginal benefit of every single person in that market. Well, during the weeks of winter break, where there's not as many students in the area, there aren't as many of those individual demand curves to add up. So you might see something like a much lower demand curve for, let's say, December games. Marginal revenue is twice as steep. So we get a much lower number of tickets sold for those December games at much lower prices. Right? So, we're really just analyzing like things that would shift demand. We can draw those shifts in demand, but in all these markets, we're going to think about these teams likely have monopoly. We're also going to have to kind of draw this twice as steep marginal revenue curve that'll be shifting downward as well. Okay. Any questions over kind of this model yet? All right, so we'll have all these things and we'll talk a little bit more about them next class. I think I want to, at 10 minutes. I'm gonna skip ahead here. I might come back if we have time. So here's kind of a nice just visualization. We've already kind of worked through some things on the board, but this would be like what our ticket market looks like. So what I want to do here is let's think about if we have a shift in supply, right? So I just kind of went through, if we thought about things that would shift demand. I don't know. We're still identifying the marginal revenue the same as the marginal cost, but there's some weird things that can happen if the supply curve shifts. Now, a supply curve shift is weird because it's unlikely we can affect the supply curve in the short run, right? We're thinking about the capacity being where our vertical supply curve is at. It's likely that these changes are going to be made like over a year, right? They might be able to do some renovations, right, to increase the capacity, or build a new stadium, right, to choose the new capacity. So if instead we're thinking about supply shifts, so maybe this is a stadium wanting to go to a higher capacity. Right? So we'll do a couple different scenarios here. So one, let's say we start out, here's our demand curve. And we'll draw twice as steep marginal revenue curve. And let's say, which one do I want to do first? I'll show you a boring one first, right? So let's assume that this is my initial kind of supply curve. How do I want to say this? I'll just capacity 1, right? So I have this stadium. Given my current demand, where's my equilibrium quantity of tickets sold going to be? Well, marginal revenue, remember, my supply curve, my marginal cost curve, is running along the horizontal axis and then vertical at capacity. So here's my profit maximizing number of tickets to sell, and the price that I would charge that maximizes profits would be wherever I'm up at on the demand curve. Okay. Everybody with me so far on that? What if I then, for whatever reason, this would not make a lot of sense, I'm currently selling at a quantity that's below my capacity. But maybe I think down the road demand will increase, right? Or I think that building a new stadium might increase my demand, right? So I build this new stadium and I build it with a higher capacity, right? So just having that higher capacity stadium, that shift in supply, what's actually happened to my equilibrium quantity and price? Where would the marginal revenue hit my marginal cost curve? I've just seen an increase in supply. It's not my supply curve shifts at the vertical portion, but it's still running along the horizontal axis up to that point. Demand hasn't changed at all. We're assuming to start out with from this new stadium. And so I would actually end up selling the exact same number of tickets at the exact same price. All right. There's going to be no difference if my demand curve wasn't high enough to kind of meet capacity there. Right? Now, if I thought there was subsequent effects, like after I build this new stadium, that maybe I'd see an increase in demand, well, then, yeah, maybe if I could see a demand curve up here that's higher, well, then maybe I do get a new equilibrium profit maximizing quantity that's higher than it was before. And maybe I can get away with charging a higher price, right? But that's only if building that new stadium, having that higher capacity, actually increase demand for, for that team's games. And that could, and more likely if I'm just increasing capacity, like not building a new stadium, just like I mentioned earlier, these minor leagues maybe opening up different parts of the stadium or different parts of the concert venue. Well, that's an increased supply, but it might not do anything to demand, right? In which case, we're going to have the same number of tickets sold at the same price. I'm generating the same revenue. But if I built a new stadium, right, and I didn't see any shift in demand, okay, I'm making the exact same revenue. But just because my marginal costs are still zero, to build that new stadium, I increased my fixed costs a lot and really ate into my profits there, right? So generally thinking about supply shifts like this might not have any impact on where our equilibrium is. Right? Questions on this before I'm gonna have to erase it. Like I said, I hate this room because we don't have two sides. But okay with this? So I'll show you a more interesting example, right? So let's say I had the same shift in supply, but when I start out, so here's my demand curve. Here's my twice as steep marginal revenue curve. Well, let's say here, I start out with this vertical supply curve that's quite a bit further back. I have a pretty small capacity stadium. So we'll call this, we'll say this was the capacity that we started out with. Where's my equilibrium going to be here? Well, where does marginal revenue hit marginal cost? Well, now I'm hitting it on the vertical portion. I've had demand high enough to where this profit maximizing quantity is actually at capacity. I'm selling out my stadium. And in doing so, if I go up to my demand curve where I'm at that quantity, I'm able to charge, this doesn't look like anything. I'm able to charge a much higher price, right? So let's say I'm starting out now as opposed to before where I was selling under capacity. I'm selling up to capacity. So what might I want to do? Build a bigger stadium, right? So now in this scenario, if I were to build kind of a larger stadium here, well, where's my new equilibrium quantity now? I've seen this shift in supply. Remember, it's still running along this horizontal axis. Marginal revenue now hits marginal costs out here. So I'm going to see an increase in the quantity that I'm able to sell, the number of tickets. And if I go up here, you get kind of a weird thing, which is, even though I'm selling a higher number of tickets, the optimal price, because I have this larger capacity, is actually going to be a lower amount. Now, from here, would it have made sense to do this? Well, I would have to know a little bit more about the demand curve. What's its elasticity, right? Because if I look at the price times the quantity, that's how much revenue I generated from my first original stadium. After building the new stadium, with this price and quantity combination, yeah, the quantities went up, but the prices went down. So if we think about total revenue being price times quantity, the price went down, the quantity went up. I don't really know whether or not total revenue went up unless you tell me how much each one of those increased and decreased by. So there would become a little more problematic. We're not going to dive into that, but you could calculate the elasticity and figure out if moving to this new stadium would provide higher number of total revenue. For now, all I want you to know is if we see the supply shift, just identifying what's going to happen to our equilibrium price and quantity in that ticket market. Okay, so it's really going to depend. Like there's not one answer every time we see a supply shift now. And we won't go through it today, but I've shown you a couple with the demand curve. I specifically showed you all of them when we had high enough demand to hit capacity, because just like with this example, a supply shift caused quantity and price to go up, whereas before they didn't change at all. Sometimes demand shifts will kind of have those, could have varied effects as well, depending on whether or not demand was previously enough to hit capacity or not enough to hit capacity. Okay. So we're running into a few issues with these ticket markets that we didn't see in our traditional kind of product markets. So I left this slide open to kind of draw out some of these graphs. We'll return to some of the other slides that I kind of skipped through. We talk about price floors, price ceilings, and then we'll go through that paper that I mentioned at the beginning of class, which before you leave, I also want you to do one thing for me, okay? So I want to try to do some troubleshooting. Hopefully when I start this up, you're able to, if you have the app, see the eye clicker for the section. For this class, you got a physical version, you've got it registered. I always leave the frequency on AA, so I want everybody to get the full 10 out of 10. I just want you to respond with any letter. I don't care what letter it is that you respond with, but make sure you get a recorded response. I've got it open right now. I'll leave it open until everyone leaves. But this way I'll be able to make sure that everyone's is registered correctly. Make sure hopefully anyone have the app having any issues seeing the section, you saw it okay. AA will always be the frequency. Get your answer in. I'll leave it open until everybody's gone. Other than that, if you guys have any questions, just feel free to email me. I'll probably get up the first homework assignment this afternoon, so you can start chipping away at that a little bit if you want. We haven't covered a lot of material yet. Other than that, I'll see you guys on Friday.